Hi, and welcome to our first video under mathematics. In this video, we'll be looking at inverse functions. So inverse functions are basically functions that reverse other functions. For example, here the inverse of this function will create a reverse route to the original function. And the inverse of this function is denoted like this. So from the above example, we can see that inverse functions are only for one-to-one functions. Now imagine a many-to-one function. How do we begin to find the route backwards? Okay, so now we can begin learning on how to find the inverse of a function. Let's take this example, f of x is equal to 3 minus 5. The first step is rewriting the function, and wherever there's f of x, we'll replace it with y. So this gives us y is equal to 3x minus 5. At this point, you can write x is equal to 3y minus 5, but I think it's kind of confusing, so I like using this step. So my next step is making x a subject of the formula. Y is equal to 3x minus 5 can also be written as 3x minus 5 is equal to y. So we add 5 on both sides, and we get 3x is equal to y plus 5. Now we can divide both sides by 3, and we get x is equal to y plus 5 over 3. The next step here is replacing x with the inverse and y with x. So this gives us the inverse of the function of x is equal to x plus 5 over 3. Okay, let's look at another example of finding the inverse. Let's say our function f of x is equal to 2x plus 1. So we begin by saying y is equal to 2x plus 1, and we can rewrite this as 2x plus 1 is equal to y. So like we did previously, we had the 1 on both sides, so we'll just skip that step and say 2x is equal to y minus 1. So we divide both sides by 2, and the x and the 2 goes on the left hand side, and remain with x is equal to y minus 1 over 2. Here we can now replace the notation and say the inverse is equal to x minus 1 over 2. And the last example we can look at is f of x is equal to minus 2 over 3x plus 5. Rewriting that, we have y is equal to minus 2 over 3x plus 5. So as we said earlier, this is the same as saying minus 2 over 3 x plus 5 is equal to y. So taking 5 to the other side of the equal to sign, we get minus 2x over 3 is equal to y minus 5. So at this point, we can cross multiply to standardize the value of x. And so that can be said to be over 1. And cross multiplying, we'll get 2x is equal to 3 in brackets y minus 5. So at this point, we can now divide by negative 2 to find x on both sides. And we get x is equal to minus 3 over 2 y minus 5. And replacing the notation, we finally get this. Now, if you want, you can always leave it as a proper fraction, but in this case, we'll just leave it as this. Now, how do we begin to tell whether the answer we've got is correct? And so now we can look at proving inverse functions. So if the function f of x has an inverse, let's say g of x, it means when we say f of g, which is just the same as saying g of x, the answer that we're going to get is x. So let's look at this typical example. Let's say f of x is equal to x squared. So the usual, we say y is equal to x squared. Now at this point, let's open a new window. Okay, so if we say a is equal to b, emphasis on the equal to sign, this means everything done at the left will be the same as everything done at the right. So a is equal to b is the same as a squared is equal to b squared. And this can also be rewritten as b squared is equal to a squared. Okay, what if we have b is equal to a squared? So this is just the same as saying a squared is equal to b. Now to find the value of a, we will square root both sides. And let's just write it here, and we can say a is equal to the square root of b. So going back to our original function, we can square root both sides and say the square root of the left is equal to the square root of the right. So now, whilst we're still dealing with square roots, let's take this example. Let's say the square root of 2 squared. and you can test this on your calculator by saying the square root of 2 squared, and you get the answer as 2. But what is really happening here? The square root of 2 squared is just the same as saying 2 squared in brackets to the power of half. That's what the square root equals to. So this is just the same as saying 2 to the power 2 times half, and the 2's cancel out each other, and we get the final answer as 2. So this thereby means the root of any value to the same power of that same root will give us the same answer. The cube root of a to the power 3 is just a. So we can therefore go back and say the square root of x squared is just x, then x will be equal to the square root of y. Therefore the inverse is the square root of x. Now let's just do a proof test. From the above, we said if f of x and has an inverse of g of x, f of g or g of f is equal to x. So the same would be correct if we said f of its own inverse of x will give us x. So from the original question, f of x was equal to x squared, and we found its inverse to be the square root of x. Okay, so going in from the original function, which was x squared, we're going to put in the value of the inverse wherever there's x. So this means where there was x, it just becomes the square root of x, then we square that. This can also be rewritten as the square root of x times the square root of x. So let's open a new window. What do we know? If we have the square root of 2 and multiply it by the square root of 2, and you can prove this by testing it on your calculators, we get 2. So this means the square root of any value multiplied by itself will give us the same value. And it doesn't matter, we can also say the cube root of a multiplied by the cube root of a will still give us a. Okay, just a quick correction where I had said the cube root of a times the cube root of a will give you a. That's not correct. It's missing another cube root. So the general principle is the nth root of a multiplied n times will give you a. So that means the fourth root of a 4 times will give you a. The cube root of a 3 times will give you a, and the square root of a 2 times will give you a. Just a quick correction. This will be corrected in the final document too. So coming back to our equation, the square root of x times the square root of x will definitely give us x, thereby proving that the inverse, that a function multiplied by its inverse gives us x. Okay, so let's try this other example. Let's say f of x is equal to 3x squared plus 2. Show that f of its inverse will give us x. So we can begin to solve it by saying y is equal to 3x squared plus 2. Rewriting this is the same as 3x squared plus 2 is equal to y. So subtracting 2 on both sides, we get 3x squared is equal to y minus 2. At this point, we can divide both sides by 3. And then we get x squared is equal to y minus 2 over 3. Now, from what we said earlier, what we do at the left, we do at the right, since there's an equal to sign. So we can find the square root of both sides. Let's just move upwards. So we get the square root of x squared is equal to the square root of everything there. And we already saw that the square root of x squared will just be x. So x is equal to the square root of y minus 2 over 3. And replacing x and y, we have the function inverse is equal to square root of x minus 2 over 3. Okay, so our original function was 3x squared plus 2. So to prove that the inverse function that we found is correct, we're going to put the inverse wherever there's x into the original function. So where there's x, in this case, we're going to put the square root of x minus 2 over 3. So we begin solving it. This will be 3 open brackets, the square root of x minus 2 over 3, close the bracket, squared plus 2. So we had seen previously that when we square the square root, they just cancel out. So we can automatically cancel out the square root because it is squared. So this becomes 3 open brackets, x minus 2 over 3, close brackets, plus 2. And at this point, we can cancel out the 3 by normal multiplication, and we remain with x minus 2 plus 2. So minus 2 and plus 2 will cancel out, giving us x as the final answer, thereby proving that this inverse we had found was correct. The last example we can try to find the inverse is f of x is equal to the square root of x plus 4. So this is the same as y is equal to the square root of x plus 4. We write in this square root of x plus 4 is equal to y. So because of the equal sign at this point, we can square both sides. And the square root of a square is just the values within the square root. So this gives us x plus 4 is equal to y squared. Subtracting 4 on both sides, we get x is equal to y squared minus 4. We can now replace the notation and say the inverse function of x is equal to x squared minus 4. But from difference of two squares, we know that we can further reduce this. So this gives us the inverse function is equal to x minus 2, x plus 2. And proving it, we can say f of the inverse of x is equal to the square root of x squared minus 4 plus 4. Here we've just replaced our x with x squared minus 4. So we can see that minus 4 plus 4 cancels out and we remain with the square root of x squared, which we've learnt is just equal to x. So on a graph over the line y is equal to x, the inverse function of x is a reflection of f of x. So if this point is 1, 0, its inverse is 0, 1. If this point is 3, 1, its inverse is 1, 3. And if this point is a, b, its inverse is b, a. How about for such a graph? What do you think would be the inverse? Remember, inverse of a function is only for 1 to 1. So this graph therefore has got no inverse, as it has got many points that are linking to one point. And just a reminder, at the beginning, we showed how the inverse is just a reverse route. We also had seen how a many-to-one function wouldn't have an inverse because one point doesn't necessarily have a single root to get back to its origin. And just in case you would be interested in having the material that has been passed through in this video, you can always find a link to our Facebook page in the description that will have all these things that have been covered as pictures. Thank you for watching and peace out.